Okay, so for today we're going to take a look at lesson 15. We're going to create and determine the area of composite figures. Okay, so we're going to take a look at some word problems. Emma's rectangular bedroom is 11 feet long and 12 feet wide, with an attached closet that is 4 feet by 5 feet. How many square feet of carpet does Emma need to cover both the bedroom and closet? Okay, as you can see, we have a couple of different measurements here, and we're going to be combining them. So again, you see square feet. Well, that means area. So even though the question doesn't say area, okay, we know that that means we need to find the area. So we're going to set up the rectangular bedroom. Okay, we know that it's 11 feet by 12 feet. Okay, now she has a closet off to the side here. That's going to be 4 feet by 5 feet. Okay, so we can label off the bedroom and then her closet. Okay, now what we need to do is we need to find the total area for both sections. Okay, now we know that area equals length times width. Now we have two different rectangulars here that we're going to be combining. So in this case, we're going to actually be multiplying two different sets of numbers. So to find the area of this, we're going to actually use some parentheses. Okay, because we have 11 times 12, and that'll get us the area of the bedroom. We're going to add that to the area of the closet, which would be 4 times 5. Okay, so we actually have two different sets of length times width, and then we have to combine them because we need it for both. Okay, so we know that 11 times 12 is 132. 4 times 5 is 20. So we add that up. We have a total area of 152 square feet. Okay, so Emma needs 152 square feet of carpet. Okay, all right, moving down now to number 2. Now to save money, Emma is no longer going to carpet her closet. In addition, she wants one 3-foot by 6-foot corner of her bedroom to be wood floor. How many square feet of carpet will she need for the bedroom? Okay, so now if we think about the picture that we drew up here, now we don't need the closet anymore. Okay, so now we're going to set up the same bedroom. That's 11 feet by 12 feet. Okay, but this time we're not drawing the closet because she's trying to save some money. Now, she wants to make one corner wood floor. So I'm going to do a little dotted line here. Okay, to show that this is going to be 3 feet by 6 feet. So this is going to be our wood floor right here. Okay. All right, so now we need to find the area for just the carpeted spot. Okay, but now it's no longer a straight rectangle. So what we're going to do is we need to do a little bit of subtraction here. Okay, so this time the area for the carpet, we're going to find the total bedroom first, which is going to be that 11 by 12. Okay, but now instead of adding, we're going to subtract because we're taking off carpet of this small section. And we're going to do 3 times 6. So this is our total bedroom, and this is the little corner of the room that we don't want carpet. So this time we're going to actually subtract. So now we have 132 minus 18. Okay, so we can set that up. And you see that we get 114 square feet. So now Emma needs 114 square feet of carpet. Okay. All right, so up here because we have the closet we add. Over here because we're taking off some carpet, we're going to subtract. Okay, moving on to number 3 here. Okay, now we're going to be given the picture and we need to find the total area. Now there's a few different ways that we could do this. All right, so one way that we could take a look at doing this is thinking about this shape and then creating smaller rectangles out of it. Okay, so what we're going to do is we're going to kind of draw a dotted line right here, draw a dotted line right here, so we can create 3 different rectangles. Okay, well now we got to wonder, well, how much is this section right here? Well, if this total line right here is 20, we see this label right here is 12. So that means this is 12 feet, this is 12 feet, and this is 12 feet. Okay, so if this is 12, that means this smaller section over here must be 8 feet. Okay, so now again, one other measurement that we need is this smaller piece right in here. So if we see that this whole thing is 15, 5 feet here, 5 feet here, that means that this right here is going to be 5 feet. So what we're going to do is we're going to find the area of each of these 3 rectangles. Okay, so first we're going to take a look at this big rectangle over here on the left. Okay, well, to find the area of this one, we're doing 8 times 15. Okay, well then we're going to add it to the area of this rectangle up here up top, 12 by 5. All right, then we're going to add it to this rectangle right here, which is also 12 by 5. Okay, so now we go through to multiply these out, do 15 times 8, so we have 120 plus 60 plus 60. Okay, so if we add those all up, we get 240. Okay, so the area is 240 square feet. Okay, all right, number 4 is a little bit different because it's not labeled for us. So what we're going to do is we're going to actually come up with some measurements that are going to make sense. Then we're going to find the area of the figure. Okay, so I see my big side down here. I'm going to say that that's about 15 feet. Okay, well, I'm going to kind of make this similar a little bit to the one that we have up top. So if this is 15, I'm going to actually make each of these 3 sections right here 5 feet, since they all look about the same size. Okay. All right, so now I take a look at my other sides. I can see this one's much shorter, so I'm going to make this about 4 feet, which means this one is 4 feet. Okay. Now, this inside line right here is about half of my outside box here, so I'm going to actually label this one as 2 feet. Okay. Now, to solve this problem, we can do it a couple of ways. We can do it like we did with number 3, and we can section it off into 3 smaller rectangles. Okay, but for this one, I'm going to walk through it like we did with number 2, where we're going to find the total and then subtract off a piece. So what I'm going to do is I'm going to actually find the total area for this entire big rectangle, and then we're going to subtract off this inner piece right here. Okay, so to find the total area, I'm going to do 4 times 15. Okay, and again, that's going to give me my total. Okay, now I'm going to subtract, though, this inner piece right here, which we see is 2 by 5. Okay, so just like we did number 2, 4 times 15 is 60, minus 2 times 5, which is 10. So that gives us 50. Okay, so this might be a little bit faster than the way that we did in number 3, because we're finding 2 sections of area instead of 3. Okay, so the area is 50 square feet. Okay. All right, moving on to number 5. Peterkin Park has a square fountain with a walkway around it. The fountain measures 12 feet on each side. The walkway is 3.5 feet. Find the area of the walkway. Okay, so we have a square fountain right here. Okay, it's 12 feet on all sides. All right, now there's a walkway that's going all the way around it, so it's going to be a much larger square. Okay, now the walkway is 3.5 feet wide, which means this section right here is 3.5 feet. Okay, so now what we need to find is we're trying to find the area of just the walkway. Okay, so again, this one is going to be kind of similar to what we did just now in number 4. Okay, so what we're going to do is we're going to actually find the total area of this large square and then subtract the area of that fountain on the inside. Okay, so to take a look, if we have 3.5 here, that means we also have 3.5 right here. So now to find the entire length of this big side here, we're going to add 3.5 plus 12 plus 3.5. Okay, so if we add that up, we get 19. So that means our outer square has 19 on all sides. Okay, so now what we're going to do is we're going to do 19 times 19 and then subtract the 12 times 12 of the fountain. Okay, so now if we multiply this out, okay, we get 361 minus 12 times 12 we know is 144. Okay, so we subtract that out. We get 217. So the area of the walkway is 217 square feet. Okay, number 6, if one bag of gravel covers 9 square feet, okay, how many bags of gravel will be needed to cover the entire walkway around the fountain in Peterkin Park? Okay, so now we're going to use what we have from number 5. So now we think about a tape diagram. Well, we have a total square footage of 217. Now each bag is going to cover 9. We need to know how many of those bags do we need. So what we're going to do here, we're going to divide 9 and 217. Okay, so we divide this out. Okay, now we see that we have a remainder of 1, so let's go back to the question. Okay, how many bags of gravel will be needed to cover the entire walkway? Now, we have a remainder, okay, which means 24 bags is not going to be enough. We're going to have 1 square foot left over. So because of that, we need to buy 1 more bag. So we're going to actually need 25 bags, not 25 or 24. So 25 bags will be needed. Okay. Again, we have that 1 square foot, so we got to buy 1 more bag to get that last square foot. So we'll have a little bit of gravel left over. Okay, but we got to make sure we cover the whole walkway.